Hello students. In the last session we have discussed about the priority encoders and the encoders. What is the meaning of the encoder? What is the meaning of the priority encoder? In this session I am going to explain about the decimal to BCD priority encoder. You have know about this one, how to convert the value from the decimal to the BCD. Means in the BCD encoders can we call it as in this session you I have already discussed and I have already explained about these things. Yes, I have already discussed about these things. Once again I'm just recall that one. Then afterwards I'm going to explain about the BCD, how to convert the decimal to BCD priority encoders, how can we work. You have seen that one. BCD can we call it as a 8421 also. One more name is 8421 code. Also we can call it. Yes, 8421, why it is called it as a 4-bit encoders can be used. 4 digits are there. For example, 1 can be write it in the decimal in the 1. It is write it in the 0001. Yes, in the 2 can we write it 0001. Sorry, 0010. 10 can we write it. Till 9 can we write it like that. But in the value of 12, 12 can we write it the ones 0001 and 2 is 0010. Can we write it in the from the decimal to the decimal to BCD? Can we convert from the decimal to BCD in this way? One more example can we take it? Right, one more example of the decimal. 26 is 2's decimal number is 0010. 6 is 0110. Can we write it like that in the decimal to the, this is in the decimal, this is in BCD. Yes, can be call it. BCD, you have know about that one. Yes. Uh, can we binary code decimal is call it as a BCD. Yes, in the how to convert the decimal to the BCD priority encoder, how can we call it? Yes, how can we call it? It's a priority encoder. How can we use the BCD numbers? Yes, priority encoder in the last session we have discussed. Priority means the which is the unknown value 0 or 1. Which one will you give the priority? I don't know that, but you can explain it. Yes, the encoder was introduced. The decimal to BCD encoders was designed using the gates. The process of the encoding is of that decoding. Yes, the decimal to BCD encoder, one of the most commonly used input device for the digital system, is a set of 10 switches. Why the 10 switches are there? Decimal number is 10 numbers. That's why it is used for the 10 switches. One for each number between 0 and 9. The switches generate 1 or 0. The switches from 0 to 9 that generates the on or off. On is a 1, off is a 0. Logic level, in response to turning them off or circuit BCD codes, the switch corresponding to that performing this function, which is priority encoder, the block the diagram is shown below. Active law input and output of the meaning of the word priority can be seen from the truth table. In the decimal are the 10 numbers are there. How can we priority can we give the BCD priority encoder? Can we see that one? This is a block diagram of the decimal into the BCD priority encoders. How it comes? A decimal to BCD, binary coded decimal, encoder is also known as a 10 lines. Why it is 10 lines? Decimal means 10 numbers, 0 to 9 numbers. To the 4 line encoder. 4 line encoder, why it is BCD is a 8421 code. 8421 code is a 4-bit numbers. It is a nibble. Yes, it accepts the 10 inputs and produces the 4-bit output corresponding to the activated decimal input shown in the figure. It is the logic symbol of the decimal to the BCD encoder. Yes, the truth table of the decimal to the BCD encoder shown in the table. This is a table. This is a truth table of the decimal. Yes, can we explain it in later? Of the truth table of the decimal BCD encoder shown the table, there are the 10 inputs corresponding 10 decimal inputs. 0, 1, 1, 1, 2. Can we take it as a number? 1, 2, 3, 4, 5, 6, 7, 8, 9. You can also take it. The 4 outputs y0, y1, y2 and y3. Y0 is a lower priority and y3 is a higher priority. 2 raised to 3 is a y0 is a n number of the inputs. Yes, let us look at the table carefully. Note the encoder consumptions. The input activated in the logic 1. Activated the logic 1. Other inputs are not activated. Why? It is the input of the number is a 2 raised to n and output is a 2. This is the encoder. Yes, that is the number. This logic will not work. Logic 1 and the other inputs are not activated at the logic 0. ನಿಮಗೆ ಗೊತ್ತಿದೆ ಏನಂತ. ಈಗ ಇನ್ಪುಟ್ ಇಲ್ಲೆಲ್ಲ 0 ಇದ್ದೆ 1 ಅಷ್ಟೇ ಆಕ್ಟಿವೇಟ್ ಆಗಿರ್ತದೆ. ಅದರ್ವೈಸ್ ಅದರ್ ದೆನ್ ದಟ್ ಒನ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಆಕ್ಟಿವೇಟೆಡ್. ಕರೆಕ್ಟ್, ಯು ಹ್ಯಾವ್ ಸೀನ್ ದಟ್ ಒನ್. Yes, you have seen in the encoder diagrams also. Yes, this is the x and the x bar. This is a truth table. You have seen that one. A and a naught and a1, y naught, y1, y2 and y3. In yesterday's session I have explained 0 0. It is a 0 here and you have seen that one. Yes, in the yesterday's class, if you are without knowing that one, you can't understand. This is the process of the 10 inputs are there. In the yesterday's 4 inputs are there, 2 outputs are there. Here 10 inputs are there, 4 outputs are there. That's it. LSD is a least significant digit or a significant bit, and the 19 represent the MSB, most significant bit. That's why I told you 9 is a most significant bit, 0 is a least significant bit. Yes, yes. Y3 is a LSB and y3 is a MSB, y0 is a LSB. Y0 is represents the before that one I have explained. It is the value is very less. This value is more. 2 raised to the power 3 is a y3. 2 to the power 0 is a y0. The truth table includes only the valid combinations. The valid combinations those have exactly the input equal to logic 1. Yes, while the logic zeros are numbers of input 10, K-map you have to do that one. You have to get the answer for that one. Boolean expressions. Yes, can we see that one? Can we see that one? This is, how can we use that one? All are zeros. The why not? These are the outputs. These are the inputs. All are 0. Which one is the priority? 10 is a priority. Next, why not is 1? Second priority. Means, can we write it like that? 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5. It is a 0, it is a 10. 1, it is a 9. 0, it is a 10. 1, it is 9. 2, it is 8. Yes, can we write it like that? Otherwise can we take it? I'm just remove that one. 0, it is a 0. 1, it is a 1. 2, it is a 2. 3, it is a 3. This is, can we write it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can also take like that also. You can take like that also. Yes, 3 is a 3, 4 is a 4. Can we write it like that one? You can get the answers very easily. Yes, the 4 number is a fourth row. Fifth is a fifth. Can we write it like that one? You can easy to get that one. Applying K-map for this circuit, you can get the answer is y naught equals to 1 3 5 7 9. 1 3 5 7 9. Odd numbers. Just remember this one. Why I am telling this one? I am not draw the K map. Why? Because of this year you have a multiple choice questions. If you have a descriptive marks, I am going to explain it briefly. Right? 11, 13, 15, 17, 19. Y1 is 12, 13, 16, 17. 12, 13, 16, 17. 12, 13, 16, 17. Y2, 14, 15, 16, 17. Sorry, y4, y5, 14, 15, 16, 17. Y3, 18, 19. You just remember this one. You have to draw the um, logic diagram for this one. Very easy that one. You can do that one. First one. You just y naught equals to what it comes. Y naught equals to what it is there. This is the output. What is that one? 1, 3, 5, 7, 9. 1 3 5 7 9. This is all are in the OR gate. That is a y naught. Yes, 2 3 6 7. Here the I'm going to draw that one. 6 is here. One more color I'm going to take that. 6 7 it is there here. 6 7 2 3. 2 is here. 3 is here. OR gate. It is a y1. Like that you have to draw the circuit diagrams here. It is a circuit diagram. It is not there one. You have to draw that one circuit diagram. You just separately OR gate you have to put that one. You have to draw it. I'm going to draw trying to draw that one. These are the value. I'm going to draw the truth table for that one. Why not? Can we write it? 1 3 5 7 9. OR gate it is a y naught. One more color I'm going to take that one. 2 3 2 3 7 6. I'm going to draw the OR gate y1 4, 4, 5, 6, and 7 can be take it as a y2. 8 and 9. 9 is comes here. 8 I am going to take extra. Just remove this two. 9 and 8 can be take it as a y3. This is the way to draw the logic diagram of the BCD to the decimal to the BCD encoder, priority encoder. Yes, this is a priority encoder. You sa- uh, you, uh, you have seen that one for the how to draw the logic circuit of the combinational circuit. It is there, or and gates, not gates, combinational circuit using of the basic gates, right? That is a truth table for the BCD into the decimal to the BCD. Decimal is the 10 numbers inputs and the 4 outputs are there. From the Boolean expression, decimal BCD encoder can be implemented by using the simply 3, 4, or simply 3, 4 or gates. Or gates are 4 or gates. You have seen that one. Yes, decoder. Decoder means it is a opposite of the encoder. It is a opposite of the encoder. It is the in encoder 2 raised to n number of the inputs. 2 uh, 2 is a n equals to, 2 raised to n is a inputs and n number of the values in the outputs. Here it is a reverse for that one, reverse, completely reverse. N number of inputs, 2 raised to n number of the outputs. For example, n equals to 2, it is there. N equals to 2, it is an input, and 2 raised to n is a output. 2 raised to 2 is a 4 is a output. 4 is a output. That is the way of the decoder. Decoder means n number of the inputs, output are the 2 raised to n number of the outputs, right? A decoder is a multiple input, multiple output. Yes, multiple number of the inputs and multiple number of the outputs. The logic circuit that changes the codes input into coded outputs where both the inputs and outputs are the dissimilar. Instance n equals to 2, 2 raised to n, and binary coded decimal decoder decoding the essential in the applications like data multiplexing and memory address decoding and 7 segment display. And best example of the decoder circuit would be an AND gates, because when it all inputs are high, the output this gate is high, which is called as a active high output. As alternative AND gates, the NAND gate is a connected to the output will be the low. Only when it is the inputs are high, such output is called it as a active low output. Means in the decoder can be used it the most of the advantage of the AND gate and NAND gate. Why it is that one? ನಿಮ್ಮ ಮನೇಲಿ ಒಂದು ಸ್ವಿಚ್ ಇರ್ತದೆ. ಸ್ವಿಚ್ ಇದ್ದಾಗ ಗೇಟ್ ಏನಕ್ಕೆ ಆ್ಯಂಡ್ ಗೇಟ್ ಅಂತಂದರೆ ಎಲ್ಲನೂ ಆನ್ ಇದ್ದಾಗ ಮಾತ್ರ ಹೈ ಇರ್ತದೆ. ಎಲ್ಲದ್ರೊಳಗೆ ಒಂದಾದರೂ ಆಫ್ ಇದ್ದರೆ ಅದು ಆಫ್ ಆಗುತ್ತೆ. ನನಗೆ ಅಲ್ಲಿ ಆಫ್ ಇದ್ದಲ್ಲಿ ಆನ್ ಮಾಡಬೇಕು ಅಂತ ನಾನು ನ್ಯಾಂಡ್ ಗೇಟನ್ನು ಯೂಸ್ ಮಾಡಿದರೆ ಸಾಕು, ನನಗೇನಾಗುತ್ತೆ ಅಲ್ಲಿ ಹೈ ಬರ್ತದೆ. ಈ ಆ್ಯಂಡ್ ನ್ಯಾಂಡ್ ಗೇಟ್ ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ವಿ ಕ್ಯಾನ್ ಈಸಿ ಟು ಚೇಂಜ್ ದ ಆನ್ಸರ್ಸ್ ವೆರಿ ಈಸಿ ಟು ಚೇಂಜ್ ದ ಆನ್ಸರ್ಸ್. ಆಮೇಲೆ ಯಾವ ಸ್ವಿಚ್ ಹೋಗಿದೆ ಅಂತ ನಮಗೆ ಈಸಿಯಾಗಿ ಐಡೆಂಟಿಫಿಕೇಷನ್ ಸಿಗುತ್ತೆ, ಯಾಕಂದರೆ ಅಲ್ಲಿ ನ್ಯಾಂಡ್ ಗೇಟ್ ಇರ್ತದೆ. ದ್ಯಾಟ್ ಈಸ್ ದ ರೀಸನ್ ದ ಯೂಸ್ ಆಫ್ ದ ಡಿಕೋಡರ್ ಈಸ್ ದ using for the AND NAND gate because of this purpose. Yes, decoder into 2:4 decoder can be called it. You just think about 2 is a input and 4 is a output. You just think that n is to 2 raised to n how much? 4. 2 raised to n is a 4. They will ask for that one. They will, in your multiple choice, they may ask for that one. The n is the 2 in inputs in decoder. What is the output? You can write it 2 raised to n. It is a 4. If it is a n is 3, it is a 8. Are you getting my point? In the encoder, it is reverse. For encoder, it is a reverse. 4 is the input, 2 is the output. Yes, you have to remember these things. That's why it is a OR gate we are using, NOR gate we are using. Here only AND gate and NAND gate. Yes. Next, decoder for the 2:4 using the AND gates. 2:4 is a similar to the multiplexer circuit. Mux is a number of inputs are less, output is more. At the same here, inputs are more, output is less. That's why it is a multiplexer. Multiplexer means number of the inputs more than outputs. That is a mux. The decoder is not restricted to a particular address line. Thus, can have more than two outputs. With two outputs, two or more than two outputs. They are telling with 2, 3, 4 address lines, the decoder circuit can be encoded. 2, 3, 4 means 2 is to 4, 3 is to 8, 4 is to 16. This kind of the combination will come for the decoder. Yes, up to 4, 8, 16 times multiplexed. Yes, output will come like that one. This is the circuit diagram of the decoder circuit. First, we have to see the truth table. Truth table is a very important. For the decoder, what I have seen that one. X and Y are the for. I'm going to take the A1 and A0 are the inputs. 0, 0, 1, 1, 0, 1, 0, 1. Here, I'm going to take the enable. Enable is very important in the decoder. Are you getting my point? Enable is very important for the encoder. Yes, I'm going to write that one. A1 and A0 are the inputs. I'm going to write just one. Enable A0 and A1 inputs 0, 0, 1, 1, 0, 1, 0, 1. There are the 4 outputs D3, D2, D1, D naught. Yes, these are the outputs. Enable is 1. Enable is 1. Enable is 0 if it is. These all are 0. Wherever you can. This is a 0 will come. Otherwise, the enable is 1 for the everything. The decoder of the n number of the output n equals to 0 in the 2 raised to 3 is D3 is D naught is high for the enable. And the same thing. It is the both are zeros. I am going to put the 0 for 1 for high for D naught. High for D naught. I'm going to take the one more color for that. It is a D naught is high. D naught is high for 0 0. And 0 1 D1 is high. 1 0 D2 is high. Yes, this is a high. D1 is high. And D2 is high. D3 is high. How can we take that one? It is a both are high. It is a 0. Remaining all are 0. This is the decoder circuit. Can we draw the K-map for that one? Can we draw the K-map for that one? You have to see in the how to draw that one. Can we see that one? Yes, K-map for that one. It is a K-map is. This K-map is very easy for that one. You can write that one. How can we write that one? For example, can we use it very easily? It is the diagonally one. For example, it is a D naught. D3 can be take it. D3 can be take it. A into B. Otherwise, this is A and B are the high. It is a A1, A naught. Otherwise, D2 equals to, what is that one? A naught bar, A naught bar, A1. Yes. Next D1 is A1 bar, A naught. D naught equals to A naught bar, A1 bar. Can we write it like that in the using the decoder line? Yes, this is a very important for that one. This is the K-map for we have do that one. If you get the, this is the answer with the enable 1. Enable 1. That's why no need to write the enable. Sometimes you have to put it in the options. They will give that one. That is also correct. Without giving also correct. Yes, this is the way to draw the K-map. No need of that one. You have to do. Right. 3:8 decoder using the NAND gate. NAND gates is how can we use in the 3:8 NAND gates. Just think of it. Instead of this one AND gate, can we use it as a NAND gate? Can we use it as a NAND gate? What will come? Just think of it. Just think of it. ಇಲ್ಲಿ ಆ್ಯಂಡ್ ಗೇಟ್ ಬದಲಿ ನಾವು ನ್ಯಾಂಡ್ ಗೇಟ್ ಬಳಸಿದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ ಇನ್ಪುಟ್ ಹಾಗೆ ಇರ್ತದೆ. ಇನ್ಪುಟ್ಟು ಹಾಗೆ ಇರ್ತದೆ. ಆದರೆ ಔಟ್ಪುಟ್ಟಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ ಇನ್ಪುಟ್ ನಮಗೆ ಕಡಿಮೆ ಇರ್ತದೆ. ಇನ್ಪುಟ್ಟು ಹಾಗೆ ಇರ್ತದೆ. ಔಟ್ಪುಟ್ಟಲ್ಲಿ ಏನಾಗ್ತದೆ ಅಂತಂದರೆ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ರೈಟ್ ದಟ್ ಒನ್. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ವೆರೆವರ್ ದ ಝೀರೋ, ಎಲ್ಲೆಲ್ಲಿ ಝೀರೋ ಇರ್ತದಲ್ಲ ಅಲ್ಲಿ 1 ಬರ್ತದೆ. 1 ಇದ್ದಲ್ಲಿ 0 ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ಅ ನ್ಯಾಂಡ್ ಗೇಟ್ ಪ್ರೂಫ್ ದಟ್ ಒನ್. ಇಟ್ ಈಸ್ ದ this is the main advantage. I am going to write 1 1 1 1 1 1 1 1 1 1 1 1. Can we write it? Here the 0 0 0 0 can be used like that. This is the diagonal can be used as a zeros. That is the difference between the AND gate and the NAND gate. This is the A1 instead of this one, A bar will come. A naught instead of A naught bar will come. Like that, this way can we write it like that. Yes, can we write it like that? And the K map will completely different. K map will be the completely different. Sorry, A1 bar and A naught bar will not come. In A1 bar and A naught bar will not come for that one. NAND gate, the separate will come. 3 is to 8 decoder using the NAND gate. Observe that each output of the decoder is truly a min terms. Min terms you have studied in the pause. Sum of the product and the product of the sum. Yes, SOP can be used at one. Resulting from accurate inputs, combination that is D naught equals to A1, A naught is a min term, M naught, which is a corresponding input, AND gate will come. Product of sum of product. Yes, can we see that one? Correspond to the input 0 0. D1 equals to A1, A naught is a min term M1, which is a corresponding input 0 1. D2 equals to A1, A naught min term M2, which is corresponding to the inputs 1 0. D3 is a A1, A naught is a min term M3, which is a corresponding of that values. Can we see that one in the inputs 1 1? Yes, this is the way to circuit implement with the AND gates. Shown that the figure, this is the circuit of the logic gates generated in the input combination. In such cases, inversion operation is performed. Inversion options is performed. Max term can be used that one. Circuit with the min terms, the figure below shows that the NAND gates, decoder using the NAND gates, each input table is giving the max terms. Input term ಏನಾಗುತ್ತೆ max terms ಅಂತಂದರೆ maximum number of the one will come that one. Maximum number of the n numbers will come. Yes, product of sum can be used that one. At given only output is low and all the other inputs are high. For example, AB equals to 1 and C equals to 0. Then the output Y6 is 0. Then the other outputs can be high, shown in the below. This is the circuit. A, B, C are the inputs. 3 inputs, N. Output 2 raised to N. 2 raised to 3 is 8 outputs. 8 outputs can be written. Yes, can we see that one? ABC equals to 3 inputs, 3 output. Can we see that one? 0 0 0 0. Which one is a high? Y naught is a 0 0 0. N equals to 0, Y naught. N equals to 1, Y1. N equals to 2. ಏನಿಲ್ಲ ಆಗ್ಲೇಗೂ ಈಗಲೇಗೂ ಇರೋ ಡಿಫ್ರೆನ್ಸ್ ಅಂದರೆ 1 ಇದ್ದಲ್ಲಿ 0 ಬರ್ತದೆ, 0 ಇದ್ದಲ್ಲಿ 1 ಆಗುತ್ತೆ. ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಮ್ಯಾಕ್ಸ್ ಟರ್ಮ್ಸ್ ಬರ್ತದೆ. ಮ್ಯಾಕ್ಸ್ ಟರ್ಮ್ಸದ್ದು ಕೆ ಮ್ಯಾಪ್ ಹಾಕಿದರೆ ಸೇಮ್ ಆಗುತ್ತೆ. ಇಟ್ ಈಸ್ ಅ ಕ್ವೈಟ್ ಡಿಫ್ರೆಂಟ್ ಇಸ್ ಅ ಬಾರ್. ಇಟ್ ಈಸ್ ಅ ಇನ್ವರ್ಸ್. Yes, this is the way to write the outputs. This is the logic diagram of that one. NAND gate using that one. This is the A and the A bar, B and the B bar, C and the C bar can be use it. Yes. Application of the decoder is Warfield flying robot with a night vision flying camera. A flying camera can be used that one. Robotic vehicle with a metal decoder. Radio frequency based home automation system. ಸ್ಪೀಡ್ ಸಿಂಕ್ರನೈಸೇಷನ್ ಮಲ್ಟಿಪಲ್ ಮೋಟರ್ಸ್. ನಿಮಗೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ಹೆಂಗೆ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸಲ್ಲಿ ಕೇಳ್ಬೋದು ಅಂದರೆ ಇದ್ರೊಳಗೆ ಇಷ್ಟು ಎಕ್ಸಾಮ್ಸಲ್ಲಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ಸ್ ಯಾವುದೋ ಒಂದು ಆಡ್ ಕೊಡ್ಬೋದು. ಅದರ್ವೈಸ್ ಇದನ್ನು ಇದ್ರೊಳಗೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂತ ಕೇಳ್ಬೋದು ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವಶನ್ಸಲ್ಲಿ. ಆಟೋಮೆಟಿಕ್ ವೈರ್ಲೆಸ್ ಹೆಲ್ತ್ ಮಾನಿಟರಿಂಗ್ ಸಿಸ್ಟಮ್, ಹಾಸ್ಪಿಟಲ್ ಫಾರ್ ದ ಪೇಷಂಟ್ಸ್. ಸೀಕ್ರೆಟ್ ಕೋಡ್ ಎನೇಬಲ್ security communications using the radio frequency technology. Can we use that as the decoder uses? If you want to draw the K map for that one, you have to see that one. BC is here, A is here, 0 1. Can we write it like that? You have to write 0 1. Just you have to write the 0 and 1. 8 0 0 0 1 1 1 0 1. Can we write it? Which one is triple zero is? Which one is y naught is 0? Like that, can we use that one? Can we remaining are the zeros? 0 0 0 1. Here the y naught is 1. Like that, can we put the numbers? Can we put the numbers like that one? You have to get the outputs. Yes, K map for that one, you can use like that. Yes, this is the way to write the K map. Yes, this is the applications of the decoder. Okay, this is the multiple choice questions. You have to search on that one. You have to, I want to give in the, after finishing these portions, I'm just discussing about the multiple choice questions for you. Okay, thank you. So please watch our videos regularly.